Hello, this is Miss Parks, and today we're going to talk about trig functions of angles that are not necessarily acute. So we've learned about SOHCAHTOA, and we learned about the 30, 60, 90 and the 45, 45, 90 triangles that we're going to be using a lot of here. And now we're going to be talking about different angles and angles that are bigger than 90 degrees, and also what a reference angle is, because a reference angle is how we're going to find these trig functions, the reference angle, and I'll explain what that is in a minute, or actually right now. So a reference angle, we write it as theta prime. Okay, so again, it's just a theta symbol with a little prime, with a little dash. Let me rewrite that neater, theta prime, and that's a reference angle. And the reference angle is always acute. Okay, and it's an acute angle, and it's the measure of the terminal side to the x-axis. So you can see here that it's the terminal side of the angle to the x-axis. The terminal side of the angle to the x-axis. So let's say the angle is 120. This would be the terminal side. Then the reference angle is 60 degrees. Okay, so here, if it's in quadrant 1 and that's 50, then the reference angle is also 50 degrees. Let's say that we're here and we're in quadrant 3, and I'm just going to throw out a number there and say that this is, I don't know, 215. Then that angle right there is the reference angle, and that would be 35 degrees. And then here, this angle here, let's say that the terminal side is at 330, and that's 360 right there. So the reference angle would be 30 degrees. So if you look at all the ones that are highlighted, those are the reference angles. I will show you an animation of that now. All right, so you can see here that the angle that is drawn is 120. The one that's in blue is the reference angle. So the reference angle is never to the y-axis, it's always to the x-axis. Okay, so the x-axis is down here. So if the angle is 38, the reference angle is also 38. You can see in the second quadrant, it's how far it is to 180 degrees, basically. So if I'm at 170 as my angle, then my reference angle is 10 degrees. Once I pass 180, we're going to see how far away we are from 180 still. So if this angle right here is 200, so we're talking about this one, then the reference angle is 20. You can see it increases until it gets up here. And then once we go into the fourth quadrant, we're trying to figure out how far it is from 360, because that's where the x-axis is. So again, if this is 320, then the reference angle is 40. So again, reference angle is from the terminal side of your angle to the x-axis. All right, so the most important reference angles that we use are the 45, the 30, and the 60. And you need to become very familiar with those because we use those all the time, and that's how we're going to do the unit circle later. So this is 45 degrees, that reference angle. That's also 45 degrees. And again, it's the one that's closest to the x-axis. So these are all 45-degree reference angles. But when we fill in the actual angles themselves, so if I'm figuring out how big this angle is from here to here, this angle is 45. If I go all the way around to this side, it's supposed to be circular, this will be 135 degrees, because I'm 45 degrees away from the 180, because this is a 180. If I go all the way here, we're at 225. And then if I go into the fourth quadrant, that's 315. Okay, so I'm going to kind of remove all this. But all the 45-degree reference angles, you need to remember those. I'm going to go ahead and draw that. And you can see that when it's a 45-degree reference angle, we're talking about this angle here, by the way, that this is a 45, 45, 90 triangle. And that's going to come in handy in a little bit. So we have 4 triangles, and they're 45, 45, 90s. Now, for the next one, we have 30-degree reference angles. So we're talking about these. And those are degrees. I guess I have a little bit of room to put a degree sign on there. So this is 30 degrees, and then go ahead and fill in all the rest of them in all the quadrants, if you would, please. And then do the same thing for the 60-degree reference angle. So I'm going to go ahead and put the 60-degree reference angles in. Then go ahead and pause right now and fill in basically all these angles, please. And then when you're finished, go ahead and unpause the video. All right, so it's 30 degrees in the first quadrant. Second quadrant, we're 30 degrees from 180, so this is 150 degrees. In the third quadrant, we're 30 degrees from 180, so we're 210 degrees. And then in the fourth quadrant, we're 30 degrees from the 360, this angle here, so that's 330 degrees. Okay, and these are all 30, 60, 90 triangles, with the 30 is the reference angle. And these are 90s right here. And we will be talking about triangles and how they affect all this. And then the last one, you should have filled in 60 degrees, 120 degrees, 240 degrees, and 300 degrees. And these are also 30, 60, 90 triangles, 4 of them. But the reference angle in this case is 60. In this case, it's 30. So the 60 is over here. It's not considered a reference angle. The reference angle always is the x-axis and then the terminal side of your angle. All right. All right. Now, we have certain values for these, which we're going to be introducing later. And I'll talk about that in a little bit, but just always think of the hypotenuse having a value of 1, and then you'll be able to figure these out, or the radius is going to be 1 if there was a circle around here. So that would be this side, like the hypotenuse, which means that the short leg would be 1/2, and then the long leg would be radical 3 over 2. Okay, but we'll talk about that a little bit more later. All right, to find reference angles, you can follow all these if you want. I'm not going to go through all that. I'm just going to show you what I think is the easiest way of doing it. So I would draw a picture, and then I would draw where the 218 is. So 218, everything starts on the x-axis. 218 is past 180. So we're in the quadrant 3. And so my reference angle will be in the third quadrant. So I would like you to put where your reference angle is in quadrant 3. And if this is 218 and that's 180, then the reference angle here is 38 degrees. Okay, so the reference angle, 38 degrees. And we're talking about this one. Now, when the angle is more than 360, then you have to keep subtracting 360 until you get to an angle that's between 0 and 360. So we're going to be doing the coterminal angle. So if I subtract 360, that's going to give me 1027. If I subtract 360 again, that's going to give me 667. If I subtract 360 one more time, I'm going to get 307. And so if I draw that angle, 307, that angle will be here. So the reference angle is always to the x-axis. Okay, so this is 307. We don't have a symbol like for reference angle. We have a symbol for coterminal angle. We do not. So this is considered the coterminal angle. And then the reference angle is the one that's in here, because if I went all the way around, that would be 360. Then that angle there is going to be 53 degrees, and that's the reference angle, which is what we're looking for. Please do these two. Go ahead and hit pause, and then go ahead and do those 2 problems. All right, so if I draw this one, that angle, 294. This is 270. So I'm 24 degrees past that. That doesn't matter at all. This is 294. I need to know how far away I am from the x-axis. And since that's 360, then the difference between these two is 66 degrees. So that's the reference angle. For this one, if you subtract 360 and then you subtract 360 again, you will get 163 degrees. This is the coterminal angle. If I draw 163 degrees, it's right about there. We need to figure out how far away I am from the x-axis. So this is 180, that's 163. So that angle right there is 17. So my reference angle is 17 degrees. Hello. For this portion, I added this in after I made the note. So it might help you to understand a little bit more. I realized that there wasn't really a ton of information. So this is an introduction to the unit circle. And in the unit circle, you will have 3 different types of triangles. You will have one with the reference angle of 30. So all the ones in blue, the reference angle is 30. Okay, so all of these, the reference angle is 30. And for all of those, you will have an x value of radical 3 over 2 and a y value of 1/2. Every single one of those. Now, the only difference is it going to be positive or negative? So every single 30-degree reference angle, all of these, all the 30-degree reference angles, you're going to have a long x value and a short y value. X and y correspond to cosine and sine. So I know we always write sine first, but just think of it as an alphabetical order. Cosine always goes with x, and sine always goes with y. So at all the 30-degree reference angles, cosine will be the long leg, which is radical 3 over 2, and sine will be 1/2. So at 30, cosine is radical 3 over 2, sine is 1/2. At 150, cosine is negative radical 3 over 2, sine is 1/2, positive. At 210, cosine is negative radical 3 over 2, sine is negative 1/2. And at 330, cosine is positive and sine is negative, but they all correspond to those numbers. When you get to the 45, those are the easiest kind. At the 45-degree reference angles, cosine and, at the 45-degree reference angle, both cosine and sine are radical 2 over 2. Okay, the legs are exactly the same length, and the legs represent sine and cosine. And so those are the ones that you don't really have to worry about as much because they have the same answer. The only thing that you have to worry about is if it's positive or negative. Since cosine goes with the x, cosine's positive on this side of the circle. Okay, and since sine goes with the y value, sine is positive up here because it goes with y, so you're going up. Okay, just remember that part. And then tangent is the slope. And since tangent is the slope, it's positive in quadrant 3 and quadrant 1 because it slopes upward in those 2 quadrants. And so again, this is an introduction to all of this stuff. In the 60-degree reference angle, then this reverses. The short leg is the x and the long leg is the y. Okay. Another way of remembering it for sine, as the numbers get bigger, the sine values get bigger. It goes 1 over 2, 2 over 2, 3 over 2. And anything that starts with a co, as the angles get bigger, then for cosine, the values actually get smaller. It's counterintuitive. So use this as a reference to finish the rest of the problems. Again, when I made the video to start with, this wasn't in it. It is now, so you can use it as a reference in your notes as well. All right, so now we're going to find some trig functions based on these values. So They want us to find all 6 of them. So we're going to do sine, cosine, and tangent to start with. And let's go ahead and put the other ones, cosecant theta, secant theta, and cotangent. So if we're doing the 6 trig functions at 210, you can look at the picture above. I always assume that I don't have a picture in front of me, right? So you draw an XY axis, you put 210 where it is, and 210 is here. That's a 30-degree reference angle. So I know for sure then that I'm going to have a short leg and a long leg. Since that's a 30-degree reference angle, the short leg, the X value is the long leg, and the X is cosine. So cosine is negative radical 3 over 2. Again, remember, short leg is 1/2. The long leg is radical 3 over 2. So short and long. The X is the long leg, and the X goes with cosine. Sine goes with Y. So Y is a short leg, and it's also negative because it's pointing downward. So if I'm going to the left, X is negative. If I'm pointing downward, Y is negative. So that's a negative 1/2. Tangent is a slope. And the way that I would suggest for tangent, if it's the flattest slope, so this is the flattest slope there is, not steep, the flat one is the fraction. So tangent has 3 possible values. It's radical 3 over 3. That's the 30-degree reference angle. Then we have 1 for the 45-degree reference angle. And then we have radical 3 for the 60. So the only one that's a fraction for tangent is the flat slope. If you forget that, tangent is always y over x, and you can do it that way. Okay, so if you do y over x, it would be negative 1 over negative radical 3. The 2's would cancel out. So if you wanted to do tangent by taking these 2, and then reducing it, then you would get tangent, which is radical 3 over 3. It is positive. It's sloping upward. Now, for the other ones, these are reciprocals. So the reciprocal of negative 1/2 is negative 2. When and this is radical 3 over 3. I don't know why I just put radical 3. So it's radical 3 over 3. The reciprocal of radical 3 over 3 for cotangent is the opposite. It's the one at the 60. So it's radical 3. Or you could just flip this over to get the cotangent. And then secant is the reciprocal of that. So if you take the reciprocal of negative radical 3 over 2, it's negative 2 radical 3 over 3. Now, I know that I didn't do the work for that. You can take this and flip it upside down. So if we take cosine and make a negative 2 over the square root of 3, and then we multiply that by the square root of 3 over the square root of 3, you get negative 2 square roots of 3 over 3, and that's secant. You will get used to this. These are always going to be the case. The reciprocal of radical 3 over 2 is 2 radical 3 over 3. And we use these all of the time. Okay? And then for tangent and cotangent, for tangent, the flat one is the fraction. And then cotangent is the complete opposite of that, which would be the radical 3. And again, for tangent and cotangent, they only have 3 answers. It's either the fraction, or it's 1, or it's the radical 3. Okay, these are your tangent and cotangent values, and that's all you have. All right, for the next part, we're doing sine, cosine, and tangent, and cosecant, secant, and cotangent. And actually, instead of theta here, I probably should have put 225, sine 225, cosine 225. I'll just go ahead and put theta equals 225. I should have done exactly the same thing here. Theta equals 210. So if you put sine 210, cosine 210, tangent 210, and so forth. All right, so at 225, Again, we're in the the third quadrant. This is a 45-degree reference angle. Those are the easiest kind. The X and the Y are exactly the same. So when you have a 45-degree reference angle, the legs are the same length, and those are both radical 2 over 2, radical 2 over 2. They're both negative because we're in the third quadrant. So negative X, that's cosine. Negative Y, that's sine. Tangent, when legs are the same length, tangent is a slope. So it has a slope of 1, and it's positive. Okay? So again, this is negative radical 2 over 2. That's also negative radical 2 over 2. For when you flip over radical 2 over 2, it's just radical 2. Same thing here. And then the reciprocal of 1 is 1. So just like here, the reciprocal of radical 3 over 3 is just radical 3. So the reciprocal of radical 2 over 2 is just the square root of 2. All right. Next, I'll do the first two, and then you guys go ahead and try the second two and see how you do on these. All right. So I don't like to do negatives, so I'm just going to go ahead and add 360 to get a positive angle. So this would be cosine of 120. For the cosine of 120, I'm going to draw a picture. 120 is here. Cosine is the X value. That's a 60-degree reference angle. So cosine is X. So it's a small. And it's a negative because it's going to the left. So that's a negative 1/2. That is a 60-degree reference angle. So I know that my answer is either going to be 1/2 or radical 3 over 2. Those are your only two choices for sine and cosine. And since it's the short leg, it will be the 1/2. And because it's going to the left, it's a negative. So for tangent, my choices are, again, radical 3 over 3, 1, or radical 3. Since that ends with a 5, it's going to be a 1 or a negative 1 because that means it's going to be a 45-degree reference angle. So I'm going to subtract 360. If I subtract 360, I get tangent of 315. So 315 is in the fourth quadrant. That's a 45-degree reference angle. Tangent is slope, and that's sloping downward, so that will be 1. Actually, negative 1 because it's sloping downward. Please try the next two and see how you do. All right, so I'm going to go ahead and try these. So for the next part, I'm going to add 360 here. If I add 360, I will get sine of 210. We just did that up there. 210 is here. If you need to kind of make sure you know where 210 and 240 is, and that'll give you a pretty good indicator of what your triangle is going to look like if you try to draw it to scale. Sine is the Y value, so it will be negative, and it'll be the short one. The short leg, which again, you have two choices, short leg, long leg, at 210, and sine goes with Y, cosine goes with X. Cotangent will be the reciprocal of tangent. So again, your three choices are going to be radical 3 over 3, 1, or radical 3. So I'm going to subtract 360 twice. So that'll give me cotangent of 60 degrees. So tangent at 60 is the steep slope. So at 60 degrees, 30, 45, and 60, this is tangent, which means cotangent will be the 30. It'll be the other one, not 1 because that's only at the 45. So cotangent will be the fraction because it's the reciprocal. Okay, so again, tangent of 60 would have been this. Okay, the one that's not a fraction. The fraction would have been the flat one, but then for cotangent, it's the opposite. And again, you can refer to this if you have questions, okay? So tangent goes in this order, cotangent would go in the opposite order here. All right, for this part, we will be doing cosine of 120, sine of 60, and tangent of 30. Let me put them in different colors so you can see which one I'm going to do. So cosine of 120, since that's 120, cosine is the x value, so it's a short leg, but it's negative. For the next part, we have 2 times the sine of 60, but then we also have to square that. So 60 is up here. Sine is the y value. So sine is the long leg, and it's positive because it's going up. So that would be the square root of 3 over 2. That's the long leg. Tangent of 30, 30 is here. So that's the flat slope, and the flat slope is the fraction. Okay, the fraction answer for tangent. If you forget, you can always just make the radius 1, and then that's 1/2, and that's radical 3 over 2 if you use the 30, 60, 90 properties. All right, which is what we're doing this whole time. Anyway, we are using the 30, 60, 90 properties with the unit circle that has a radius of 1. So then the short leg is half as much, and the long leg is radical 3 times as much. Okay, and then for the 45, 45, 90, if the radius or the hypotenuse is 1, then each of the legs are radical 2 over 2. Okay, and then for the 30, hypotenuse is 1, which means the short leg is 1/2. Okay. All right, so let's go ahead and finish this up. In this case, we're going to have negative 1/2 plus 2 times, and we have to square this first. So we square the radical 3. We square the 2. So then we have negative 1/2 plus, if we reduce this, we're going to have 6/4. So that's 3/2. If I combine these together, I get 2/2, which is 1 minus radical 3 over 3, and you can just leave your answer like that. If you wanted to combine those, you could, but you would have to, it would look just as messy. It would be 3 over 3 minus radical 3 over 3. So it would be 3 minus radical 3 over 3, which just go ahead and leave your answer like that. All right. For the next one, I'm going to do sine of 45. So 45, sine and cosine are both the same. They're both radical 2 over 2. And then you have to square it. For the second one, I have to do cosine of 135. So 135 is here. And that's a 45-degree reference angle. Again, sine and cosine are the same. Cosine is negative because it's the x value, and we're going to the left. So negative radical 2 over 2. And then for tangent, 225, this is a 45-degree reference angle. That means it has a slope of 1, and it's positive because it's going upward for tangent. So that's 2 times 1. When I square this, I'm multiplying radical 2 times radical 2, which is 2, and then 2 times 2 is 4. I know that's 1/2. I'm just going to do that simplified in the next step. We're going to square this. So again, that's positive 2, and then if I square the bottom, that's 4, and then that's minus 2. So this is 1/2 plus 3 times 1/2, so 3/2 minus 2. So if I combine these two together, I get 4/2 minus 2, which is 2 minus 2, which means the answer is 0. go ahead and do these 4 problems, please. Find the coterminal angle first. It'll be easier to do it that way. And then see if you can answer the rest of it. All right, so if I subtract 360 twice here, do them first and then check after you have them. You're going to get cosine of 60. 60 degrees, cosine is the x value, 60 is up here, cosine is the x, and the x is the short leg. For 405, if I add 360 twice, I will get cotangent of 315. If you just want to add it once, you could do cotangent of negative 45 if you wanted to. That's down here. So I will do tangent first at the 45. Tangent is equal to a slope of 1 because it's sloping downward, it's negative 1. So tangent at 315 equals negative 1. Cotangent is the reciprocal of that, which is also negative 1. If you go back to the list we made over here, for tangent, they go in this order, these numbers, for the 45s and 60s. And for cotangent, they go in the reverse order. So it would be radical 3, then 1, and then radical 3 over 3. Okay, for the 30, the 45, and the 60, you just have to determine if it's positive or negative. Tangent's positive in these two and negative in these two quadrants. For number 3, I'm going to go ahead and subtract 360 from that. So I will get sine of 225 degrees. 225 degrees is here. That's a 45-degree reference angle. The x's and the y's are exactly the same. They're both radical 2 over 2. Sine is the y value. And it's pointing downwards, so it's negative radical 2 over 2. And then for this last one here, we're going to add 360. We're going to have to do that 3 times. You don't have to show that work. I just wanted to write that so you would see that. So that's cotangent of 150. So 150 is here. It's this angle. So tangent is negative, which means cotangent will also be negative. This is the flattest slope. And so for tangent of 150, it's going to be the fraction, radical 3 over 3, which means for cotangent, it's not going to be the fraction. It's going to be the one that's not a fraction. So again, tangent and cotangent have 3 values, radical 3 over 3, 1, or radical 3. For tangent, the fraction is the flattest slope, and for cotangent, it's the opposite. All right, so for these two, they're asking you for theta. So we want to know where cosine is equal to negative radical 2 over 2. So the way that you would do this problem is cosine goes with the x. So we want to know where cosine's negative. So cosine's negative on this side. Okay. Why? Because that's where the x's are negative, to the left. So I know for sure it's going to be one of these two quadrants. And then the radical 2 over 2 is always at the 45-degree reference angles. So this is 135, and this is 225, and that's where cosine is negative radical 2 over 2. So 135 degrees and 225 degrees for theta. Try this one. All right, sine goes with the y variable. We need a negative y variable, so negative y is in the below the y-axis, below the x-axis, excuse me. So you're going to have your answer in one of these two quadrants. Sine is radical 3 over 2 when you have a 60-degree reference angle. So I need a 60-degree reference angle here, and I need a 60-degree reference angle there. Okay. So those 60-degree reference angles gives me the long leg for the y, and it's negative because it's pointing downward. Okay, so if this is 60 degrees here, and that's 180, then this is 240 degrees. And if this is 360 and this angle is 60, then this is 300 degrees. So those are theta that give me that. This will definitely take more practice, but we will be doing this all year long.